Hello, Internet. Today we're going to start our July project month. I don't actually know how this is going to go. This is sort of an idea that I've been working on, but I want to build full projects every week for a month. And so I don't really know what the process is going to be. I'm going to try to get something to happen every day. But the idea is we are going to start a new project on Monday. That's today. And then we are going to complete it by the end of Sunday that same week. And so hopefully, whatever it is, we'll get it done, and it'll give us an opportunity to kind of learn things. I'm trying to target things that either I want to learn more in, or that are going to explore areas that I haven't explored previously. That's sort of the goal here, is sort of to give me a way to try those new things. So think of it like a recurring hackathon / game jam or whatever. It might be games, it might be other projects, I don't really know. But I just thought this would be fun. With the way 2020 has gone so far, I have no idea if this is a schedule that I'm actually going to be able to maintain. It seems like something new happens every month, and it seems like it just keeps getting crazier. So we're gonna try this, and hopefully it goes well. But that's that. They may come out as YouTube videos, or they may come out as Twitch live streams. If I do anything on Twitch, it'll be rebroadcast on YouTube somehow. I don't know exactly how this is going to go. But if you want to catch those, you can catch me over at twitch.tv/worldofzerodev. I'll put a link in the description. That's where you catch that. Anyway, this will be less formal, so we're just going to get started and figure things out. There's going to be a lot of like Googling and figuring things out to kind of work our way through these things, because the scope is bigger and less well defined than in some of my other videos, if that makes sense. Where previously we may have worked on something that could be contained into 30 minutes or an hour. Now the goal is something that can extend beyond that. And so there may not be clean cuts between these things. We may just get to the end of my time and then have to pick it up the next day. That's just how this might work. But we are going to be building a health tracker app. So the idea is we are going to create a database that I can own, and then also some sort of dashboard so that we can actually browse health data. I'm not going to be publishing any of that, but I just want something that I can use to track specific things that I care about in a way where I control that data. And so I'm not worried about who's getting what information, who I'm paying for what, and also who they're giving that information to. This sort of gives me control of that. And so I know a number of people have used this. I think Scott Hanselman, for example, has his own project where he uses that to track his blood glucose levels for diabetes. And so there's opportunities there. That is not something that I am particularly keen on solving. That's a different and more complex problem that requires a little bit more care. This is more just like personal health, like weight and height and things, like general things. I don't know exactly what we're going to track, but that's the idea. It seems like a fun way to kind of explore this, and get me back into working with databases and doing some service things that I haven't played with in a few years now. So that's where we're going to be playing with. And hopefully some of the tools we're exploring are going to be things that you can use beyond just a health app. That isn't the goal here. I'm hoping a lot of what we're covering in these is going to cover things that you can take beyond these specific projects and apply to a whole bunch of different things. In this case, we're going to be using things like Grafana and Postgres. And both of those are things that you can use for a whole bunch of things. You can use it to monitor the health of your applications and not the health of you. So yeah, that is that. So I just have this empty health tracker app or folder. There's nothing here. So what we're going to do, I think initially, is get the project set up. And so the way I'm going to do all of this, the way I'm going to kind of orchestrate all of this, is just use Docker. So we are going to have a set of, I think, 3 containers is sort of how I have it planned. We're going to have one for the database, one for our dashboards, and then a seed image that is going to run to create the initial tables and put any data we may need directly into the database. So that should only be needed to run once, but it's just there so that if when we're starting all of this, we have something that can initialize things. I don't know if we're going to get to that now, but at least initially, I want to actually get the Docker images running and actually get that so I can run Docker Compose up and get a Postgres and a Grafana container, and hopefully be able to connect my Grafana to my Postgres. We won't be able to read any data from it because I'm not intending to create a table, but we might get that far. So we'll see. Hopefully it's not too difficult. So if you've never used Docker Compose or Docker, they are a way of managing containerized things. So if I open up this, let me make this bigger. That might be a bit big, but we will play with that. So, all right, all sorts of things I want to update. Containers are a way of isolating specific things and making them reproducible. And so what this ends up giving you is a way to say, I'm talking about Postgres and Grafana images or containers. They're isolated things. And so I can just, instead of trying to code this thing or install it locally on my machine, I can just say, start this up. And it will create an isolated thing that is isolated from the rest of my computer, which means other things installed in my computer aren't or shouldn't impact this. Because it's running inside of that isolated container, it can define its own environment and kind of keep itself contained from everything else that's going on. And this allows you to run multiple things without worrying about how they might crosstalk and interfere with each other. And so it can hopefully make things a little bit nicer for you. The other thing is it's all just one image that you can reproduce and put anywhere. Assuming wherever you're running it matches the system requirements for the image you're running. And so the advantage of this is I can take this solution that I'm building and put it on my actual server that runs 24/7. I can put that there instead and actually have it be more stable than where it would be. Or I could put it in some cloud service or something. And most of my code isn't going to need to change. Everything that I'm doing locally should be pretty much the same. It's just the environment that's changing around it. It's just what's actually running it. So that's sort of the advantage there. We can see what I have running. I shouldn't have anything by just doing docker ps. If you don't have this installed on Windows and Mac, you can do Docker Desktop. That is probably the easiest way to get started with this. On Linux, it gets more complicated, but there should be an installer. It might change by your distribution. I'm not entirely sure. So Docker PS will show us all of the running processes or containers that we have. We don't have any. We also need to create a Docker Compose file. So I was talking about Docker. Docker Compose lets you compose things. It allows you to bring multiple individual images and create a group of them. So in this case, I talk about our health tracker app is going to have a database and it's going to have a dashboard. So those are two separate things that we want to run. And both of them need to run at the same time. So they both need to be able to talk to one another. They need to do a bunch of things. And so we can define them inside of this Docker Compose, and that is going to allow us to define the network so they'll be able to talk to one another. It's going to allow us to configure them in the same place. And then we can just start both of them simultaneously using a single command. Instead of needing to manually start each of them and keep track of all of the services we need to start, this lets us put them all in one place. So that is the advantage of a Docker Compose file compared to just not using that. So that's what we need. I need to figure out how to structure these files because I always forget. There's a version, and then I think it's just services. It's been a while. It's always one of those things because I don't do this often where you forget. So there are a few things that are happening here. One, there's a version for the compose file that we're using that just maps to the Docker version. So Docker version, I think. Oh, there's more things here than I thought. I don't remember how this maps. So that was a poor example. But that's generally how this works. There is a version of the schema for Docker Compose. This is defining that. It's telling Docker which schema version to use. Then there's a list of services. These are our individual containers, and they're all named. So this is a dictionary, so key value pairs of them. And so they're going to have a name, and then they're going to have a bunch of values associated with those. And those are going to define what the actual thing is, any environment variables, any ports you need to expose, any of that kind of thing. And so this web app name, we can change that. We can call that whatever we want. So we are going to call this the health DB because we can. And so we have build here. This is saying build a specific Docker file. So Docker file is a special syntax for Docker that is going to define an image for you. So Docker files are actually the name of a file. It's pretty explicit. This one lets you rename it, but typically Docker doesn't like when you do that, or didn't used to. I think it's fine now. But this will let you point to that. And this is sort of a way to actually force it to build an image for you. And so that's going to actually run through the process of building the layers that are required to recreate whatever environment it is that you need to create. We don't need to do that though. We should, I think I have some IntelliSense here. I have some docs as just a courtesy from some extension that I installed a long time ago that I don't remember. We want an image instead. And so what I want to do is track down what that image is. And so we can go over to Docker Hub. I've prepared a few things beforehand just because it doesn't make sense for us to do all of this by ourselves. But we can grab Postgres and we'll need a version. Let's just run Postgres 13. I don't know enough about the version, so we're going to take the latest. And what we're going to do is say we want to run Postgres 13, not 30. That might take a while. So this is actually the colon is separating the version or the tag from the actual name of the image. And because we don't have a URL in front, it's going to look at Docker Hub instead of somewhere else. We could be more explicit here, or if you have like your own image, image registry. Is that what they're called? I think that's what they're called. But this will get this will go and look at Docker Hub. But if you have a private one or somewhere else, you would need to be a little bit more explicit about that. We're just going to use the public things because we can, and that just makes sense. So that's that. Pretty much just saying run that. I think that's all we need there. And then we want a health dashboard. And so when I actually start running these names are going to matter a little bit because they're going to be the names that Docker uses. It will, I think it's because I'm just using them this way. It's going to throw some sort of hash there. But this should give us just a really quick way of kind of doing all of this and be able to kind of more quickly distinguish them. So we want to go and find Grafana. Grafana is a dashboard for all sorts of things. So you give it a data source. It can be Postgres, or it could be some time series database like Graphite or Influx. And then it is going to take those and be able to create, nope, there's no pictures. We will get those in just a sec. So we want to grab Grafana/Grafana. Okay, that's interesting. They skipped version 6? That's odd. Is this the right Grafana? The official Grafana? Yes, I think so. All right. I'm pretty sure this is the right one. It looks like the right one, and I've used it in the past. I'm just confused why there's no version 6. Maybe I'm missing something. Maybe I've overlooked something in the past. But we'll do this, and we want to run. Let's run their beta. So this is just a dashboard. I would care more if it was the database, but it's not the database. So yeah, I don't think these colons are going to be a problem in YAML, but YAML is weird and finicky. And so it might think that that's a second label for this thing, because you see the syntax for YAML is a string followed by a colon, and then we have another string with a colon in it. It could interpret those. YAML does weird things. So I'm going to actually just quote these just for some safety there. We could leave it and see if it breaks, but meh. We just won't. So we've done all of this. We should have, if I list everything there, we have a single Docker compose. And so if I run docker compose now and do up, what this is going to do is find a docker-compose.yml in the current directory, and then it is going to start those images. So this should start two things for us. It should start Postgres, and it should start Grafana. Before it's doing that, you'll see it's pulling a whole bunch of different things. Docker images that's unfortunate. Docker images are composed from a series of layers. I had mentioned this before. Each of those layers is pulled separately, and then the final layer is the actual one you're using. But the entire thing is kind of built from those. And if we get into actually building things, which we will when we're actually initializing this, I'll talk about those more. But that's sort of where we are with this. So it looks like we pulled Postgres, but we didn't get Grafana. It can't find the manifest, so this version doesn't exist. Okay. We could pull that, or we could pull the latest tags. This will be more useful. Master Ubuntu 7.0.4. There we go. I should have just looked here first. You can see there's some specific Ubuntu images. Those probably are what we want, but we're just going to do the 7.04. Again, this is just a dashboard, and it's just for me. There's no... We can ignore a lot of the things we might need to do in other projects that involve things like optimizing this, because it's my own hardware, and I really am not going to use it that often. And even if I was, it isn't going to be that big of a deal. This is something that we can throw on a Raspberry Pi and just kind of let lie, and it should be fine for a very, very long time if we do this right. So we should be able to run this. It should hopefully find the image. You can see it's now pulling that one. And once this finishes, we should start seeing that. Neither of these services are configured at this point. So you might have seen there was some things to actually configure these things. I did none of it. We didn't provide any ports or anything like that. So there's no way for us to reach either of these right now. There's multiple ways that Docker is going to do its network. And the default one is the bridge networking. The other one is host and something else. I don't really know what the other one is. Host networking means it's going to share with your host, which would be my computer. That means that anything that you would be able to do locally, you're going to be able to do to your Docker images. With a bridge network, it's a little bit more complicated, but it's also nicer, I guess. There's a reason it's the default. The advantage of this is that these are not they're not shared directly with our host or with one another. These ones can probably talk to one another. So Postgres and Grafana can talk. But that is a side effect of using Docker Compose. That is not the default behavior. What this is doing is giving each of the Docker containers their own separate way of communicating. And so the advantage of that is if you are using some, let's say you're hosting a web service, and that web service is hosted on port 80. If you need to host two web services, you can't, because they're both going to try to use that same port, and only one can. And so by using this instead of, say, a host networking, you're actually able to, because you're able to map specific ports in your container into other ports. And so in this case, we would need to configure that because we haven't. But that's sort of the advantage. That's why this is nice. Because, say, Grafana is going to be a dashboard. If I had another website running, they would conflict. And so one of them would break and not work. By using bridge networking, we kind of avoid that. We just have to deal with this extra little bit. So yeah, that I think is my entire spiel on that. We'll see. I might get back to it. But anyway, this works. If I open up another terminal quickly and do a docker ps, we only get one. Okay. That's interesting. But I think we can docker logs. What do we call this? Health DB. Health. Hold on. Health tracker _ health DB 1. Did I get that right? Great. Okay. We tried. We're going to give these some names. Specifies the name of the externally defined network. Okay. Custom container name. Let's do health DB. And container name health dash. This is going to give us a really quick way to reference these, and it's going to mean that I'm going to be able to more easily pull out logs. We could get a bunch of other logs from this, but this will be easier if we just stop this. You can see it automatically brings down the health dashboard. So if I do a docker ps, it doesn't exist anymore. And so if I start these back up, that happens, and we can stop this right away. And Postgres died again. So we want to do a docker logs health DB. There we go. Database is uninitialized and super user is not specified. Okay. So here is what actually happened with Postgres. You must also use post blah connections without password. This is not recommended. So it's just dying. So we need to give it a password in order to actually set up a user. This is not probably best practice. So we have some issues here because generally you don't want secrets in your application config. That is usually not a good idea because what's going to end up happening is you are going to check this into some commit somewhere, forget about it, and push it to some public repository or even a private one. And then suddenly these credentials are just floating around wherever. And so anybody can grab them and do whatever they want with them. And they're not very useful at that point. So generally you don't want your credentials inside of your configuration. You want some way to inject them. There's a lot of ways to do this. We're probably just going to use environment variables. I think that should solve it for the most part. I don't remember how to do this. Environment. And I think it's done using a list. So environment with a list of the environment variables is my understanding. I could be wrong, so I should actually look that up. Let's go here. Args. This should be defined somewhere under environment. Yep. All right, so yeah, it is a list and sort of defined like bash style. So if we go here, we want our, I don't want to do that, do it. Oh yeah, Postgres password. So this is going to create an environment variable inside of the container. So inside of this running container image, we're going to have some environment variable specified with this value. And then the running container is going to read that and use that to set the password for our new database, our database user. So yeah. Anyway, what we want is some way to more nicely get these in here. Because this is all local and I'm not going to be sharing the actual stuff with you, we can kind of cheat, I think. And so we should, hold on, let me go back here, go back to Postgres. They're going to have some sort of tip on setting up a Postgres password. Restart always, we should remember that. And ports, that's also a good thing to remember. Image adminer. I don't know what that is. That might be worth exploring. So Postgres password, Postgres user. What's the default if I don't specify one? Postgres is the default. It looks like. Yeah. So Postgres is going to be the default username. That's fine. We need a password though. And so what we're going to do, the Postgres image sets up trust authentication locally. So you may notice a password is not required when connecting from localhost. Okay. So we may not even need the password for local connections, but that is fine. What we're going to do though is use this $sign to kind of reference an environment variable. I think this is how this works. I'm not entirely sure though. So we're going to guess, and then when it explodes and doesn't work, we're going to try something else. I'll probably look it up. So Postgres password, we are going to go and grab our Postgres password. So ignoring the fact that these are the same, this is going to come from my machine. Wherever you are running this script, it is going to pull this. And so it should hopefully read this. That's not how you do this. This is PowerShell. Crap. Oh. There we go. So that should assign a Postgres password. So if I echo Postgres password, we'll get password. And so hopefully the password is Postgres and is password, and our username is Postgres. That is the goal. Hopefully that ends up working, but we will see. And then I need to expose some way to access this. I don't actually, off the top of my head, I don't remember the port for Postgres. So I don't know how to access this once I create it. That's important. So we are going to figure that out. And then we will get on to doing the Grafana bit, which is actually, do I need to expose Postgres? I think no. This may be a mistake, but I don't think we need to. So I'm saying it could be a mistake because once we do this, I have to actually remove the images if it's not configured the correct way. I can't go and expose a new port for an existing image. One of the things that Docker is really good at is orchestration of things. When I'm saying that, I mean the ability to actually manage services for you, to actually make it possible to automate and just make that cleaner. The problem with that is it's very much designed around the idea of if things aren't the way you want them, throw them away and build the same thing again. And so if we don't configure our ports correctly, we don't go and correct them. We remove it and then get a new one. And so it's not going to be that big of a deal, but right now I don't have anything persisting this. I don't have anything saving this database anywhere persistent. If I get rid of the container, I get rid of the database. And so if I do a bunch of work to actually start creating things in this database, and then realize I can't actually access it because of a port or something, I lose everything. So that's something we need to just be aware of. The reason I'm saying we don't need to care or don't need to expose any ports on Postgres is because I can exec into running containers via Docker. So I don't need it exposed in order to access this container. And I don't have a service at this point that needs to invoke Postgres, that needs to actually call out to it. And I do need to connect to it through this Grafana database or Grafana dashboard, but Grafana is going to be part of the same network. And so docker-compose automatically should be creating a network for me. It's not defined here, but I believe it's a default behavior where every service in your docker-compose file is going to be created under the network. And it should be exposed internally as health DB to everything else in that network. And so I shouldn't need anything special configured in order to be able to actually access this database. That is my understanding. So that's what we're going to try. There is some default stuff for Grafana though. We need to expose a port here. Otherwise we're not going to be able to access this. So I need to do that. And I don't remember which ones, but they had something in their README, port 3000. We could have actually read the logs there. It was in the logs up here somewhere. I don't remember where, but there was a port 3000 being exposed in the logs somewhere. So this is done doing this, I think. I need to go and look this up. Ports. Yeah, okay. So you can expose a range of ports or just a single port or whatever. We're just gonna do this. This will accomplish what we need. I think just using 3000 would be a shorthand for this. It would accomplish a similar thing, but this is fine. So that should be enough. That should give us a dashboard on port 3000. So that's how we're going to actually interface with this. So if I run this now, hopefully, we should get 2 running things. And this is going to spam a whole bunch of things because everything's initializing. If I switch over to this other thing though and do a docker ps, we'll see 2 running containers and they have the names health dash and health db. So those are both there. And you can actually see, this is kind of weird because it's wrapping, but you can see Grafana here is exposing port 3000 to our port 3000 locally. So that's how we're going to actually access this. So if I go here and run localhost 3000, we end up at Grafana's login page, which it occurs to me I do not know how to use because we don't have a user. I didn't recall us needing one. I thought there was some admin. Let's just try that. Admin. Nope. All right. Oh, it did work. All right. Admin logs us in, but we need to change our password after logging in. So we'll just do that. This can just be any password. Because we are changing this, it's all going to go away. Every time we remove this image, all of that's going to go away. Any dashboards we create here, because nothing is persistent, nothing is going to stay. We lose everything if we remove it. And I know I'm repeating myself, but I feel like that's something that can really bite you if you aren't paying attention to it. Unless you make something stay around, it is not going to be there when you come back to it. If you remove it and say we want to start again, everything else is gone. So anyway, we want to set up a data source. So we want to add a data source and we want to, there's a whole bunch of things here. Different cloud providers, different other databases. These are time series databases, which is sort of what Grafana is best at. That's sort of the thing that it does really well, is showing lots of data like time series databases and graphs over time in a really nice way. But we can also use other things. Where even is it? There it is, Postgres, select. All right. So we need to give it a host name and a database name, which doesn't exist. But we should, hopefully, be able to give it the host at least. And so the host should be HealthDB. I could be wrong here. It could be without the hyphen, but this will actually tell us if it's the container name or the service name. I'm pretty sure it's the service name. But we will figure that out. So we're going to connect to HealthDB, just HTTP like that. And that should be enough to actually get us connected to it. I'm pretty sure. Could be wrong again, but we need Postgres and our password. SSL disable, I'm pretty sure, because local and I don't have SSL certs. I don't think that would work. So we're going to disable that. Again, local stuff, this is not going to be exposed to a network. None of this stuff is going to be exposed anywhere outside of my internal home network. So hopefully that should be fine. That's sort of what I'm building a lot of this on. What we need is to create a database though, because we don't have one. And so there's nothing for us to actually connect to. Postgres SQL, save and test. Metric request error, we can't actually connect because we don't have a database. So let's create a database. How do we do that? Create table. I had pulled this up before because I was hoping we would get this far. So create table. It has been a long time since I've tried this. So we are going to not look at this. Actually, I don't really like this. This is too much. There we go. Much better. So let's go into our database. And so in order to do that, we can just do docker exec. IT is going to give us an interactive terminal. It's going to allow us to actually take over whatever process we start and interact with it. So it's telling it to wait until that process exits and also to allow input and output. So we're going to exec into our health DB. And we want to run bash. So now we're inside of that container. That's all we needed to do that. You can see my user has changed to root because that's just who we are, and everything should be fine. So anyway, we need to do something. What were we going to do? We were going to create a table, Postgres, something. Create. Actually, how does this work? You've run that, right? Unprivileged user ID to prevent. Ah, I see. We can't do this. Is there a way to start that as somebody else? Maybe? I honestly don't know. I've never really tried this, so we're going to explore it and see what happens. Probably nothing good, but who knows? Select single user mode. Yeah, root execution is not permitted. Got it. See the documentation for more information on how to start the server. Problem is, we are in a container. Postgres isn't the thing, right? There's some other. Oh, what was it? Am I mistaken? But Postgres is the process to actually run the server. There's something else to interact with it, to actually send this stuff. Right? Postgres CLI. All right. Where are we going? There we go. That was the word. pSQL. Got it. Okay. So this is what we want. We just need to figure out who our username and password are. So u equals Postgres force password prompt. How? Oh, it's going to ask me for, or it's not going to ask me for a username. Okay, I'm doing this very wrong. There we go. Perfect. Why didn't it ask for a password? Weird. That's odd. Okay. For some reason, I didn't need a password prompt. I'm not entirely sure. Again, I typically am not executing into my containers to create things, but we're kind of cutting corners here. Hopefully so that I can do this, connect all of our stuff, and then wrap everything up. And then we'll work on automating this tomorrow. That's the goal. So what we want to do is run this create table command. And we want to create health. Yeah, that doesn't sound like a great idea, but that's what we're going to call it. And so we want, I forget the syntax here. Not that, or that, this. So it's the column name, and then the type, and then any extra things that we need. So we need a name, which is a I don't remember any of my types. It's been a while. So let's do a varchar of 40. Is that going to be enough? It's a sample. Doesn't matter. Varchar of 40. It can be a not null. And do I need commas here? I do. Of course I do. Oh no. That's unfortunate. I don't know how to go back. Let's see here. Nope. How would you even? Okay, so it's not the arrow keys and it's not page up and page down. I'm confused because typically like Vim stuff, you would escape and then, oh, did that actually work? No. No, it didn't. All right. I don't know what I'm doing. We'll do not that. That will just close it. Let's do something else. We getting confused, but that's fine. Let's store a timestamp. Timestamp of something. I don't actually know the thing to store timestamps. They use an interval here. I don't think that's what we want. I'm pretty sure we want Postgres date time value. Is that what we? Here we go. They have a whole section on it. Interval time timestamp. Perfect. And we probably want it with time zones. So we need to do with time zone. Otherwise, things will just get confusing because we won't know when things actually happened. We can solve that by actually explicitly like saying everything happens at this such and such a time. But time, we'll do created time. Again, all of this is going away. So whether or not it's worth all of this extra effort, I don't know. But we will push on. Create a timestamp. This is also going to fail. There's a syntax error. But anyway, I'm sure it's all right. Where was I? We also want some sort of primary key. Do I need a primary key? Probably should have a primary key. It's probably fine. Nah, we should probably do that. Anyway, let's add a value. So we are going to do float. I'm pretty sure that's a thing, and that will also not be null. And that's it. That's all we're gonna do. Did that do anything? Oh no. Probably should have seen that coming. All right. For whatever reason, this works now. If it's obvious that I haven't poked at Postgres in a while, it should be. I haven't touched it in a while. There we go. That should create our table. So we should be able to select star from health, right? So we should be able to pull anything from that. So we can also insert something foo into health. And that is how we are actually going to test this. But now that this exists, we should have a health database that I can connect to. So if I save and test this, we get an error. That's unfortunate. Why? Data source updated. Oh, okay. Now it seems to actually be giving us a health does not exist. So that health table doesn't exist. It should though. That's what we created. So what am I missing? I'm missing something. Postgres 13. Do I need to select a different version? Ah, that could be part of the problem. Only supports up to 10, really? Okay. I honestly haven't kept up with Postgres. If we were going to do this like seriously, if I was actually going to like fix this and make sure that everything was good, we'd do that. In reality, I'm probably going to have some more complex thing for this to actually make it work. This is mostly to kind of get the entire MVP out and make a full working version of this before I figure out where I actually want the data to be. One of the advantages of choosing Postgres is there's lots of good managed options, but there's also options that make it fairly easy to kind of put wherever I need to. And so we can we don't need any of the fancy settings for Postgres. So we can change the version if we need to. It's going to require us to mess a few things up. So if I do this and change that image, one, we're going to need to repoll our image, but two, I'm going to need to rerun this. So we're going to copy it. There we go. All right, cool. Let's stop this. And we should just be able to restart things. Grafana should just pop right back up. It should maintain everything else. Postgres is not going to have that benefit. We're probably going to lose everything there because we're creating an entirely new container for this. We just gave it a different version so you can see it's pulling new things and just start it up. Cool. So if we go back to Grafana, there we go. It's confusing because I have their documentation up here and then I have the actual thing here, and they're different. No such host at 10. Okay, that's odd, but that should be okay. If I go here and exec into our Postgres database died. Ah, okay. So what we did is, let's do docker compose down. That's already done. Docker rm, we've already stopped the health DB, so I'm just going to remove it. It ran into an issue because it had been created with Postgres version 13. Because we didn't lose our data, we just ran a different image and it pulled, because they shared the same name, it just tried to reuse everything. But that doesn't work. So we're just going to wipe it out. And now that image should no longer exist. Or that container should no longer exist. The image is the same. So hopefully we should get something and it shouldn't crash. Database system is ready to accept connections. So that looks more promising. So if I run this, health does not exist. And so I should be able to come over here to our second terminal, exec into this, do piece equal to dash username equals Postgres. There we go. And then we should be able to just create our table. I think that works. And then run this. I'm starting to think I may have needed to do that. Syntax. Oh, we didn't need to switch our. I had never completed the command because I forgot a semicolon. We didn't need to do any of that. Oops. So that's a learning experience, I guess. But there we go. We should have a new table now. So if I do select star from health, semicolon, there we go. We get nothing. So there's nothing there, but we do actually have our stuff. So I should be able to go here and save and test. Oh, why database health does not exist? Password. It really doesn't like that. Password authentication failed for user Postgres. Okay. Reset. Password. Okay. I'm really bad at this, apparently. Can't type password. Health does not exist. What? No. This was supposed to fix things. Okay. This part I don't have an answer for. Because we get metrics errors when we try to access HealthDB somehow, some other way. And then the database does that. I'm wondering, do I need to insert something? So if I do insert, I think it's insert into is the syntax. What is Postgres insert into table? Yeah. Okay, got it. So insert into, we want to insert into health with the name, created, time, and value, with the values of weight and created time of now. I will need to check that there is a constant in Postgres that represents the current timestamp according to the server. And so that will actually just make sure we don't need to encode anything. Every time we run it, it will just give us some new value. So value, we'll just say 100, because why not? We're going to be changing that just kind of to check the graphs. But hopefully, there is a way to do times. How do we do that? Data hour, then those are what we want. Timestamps. I don't know. Timestamp with time zone. So this is how you would create it without using a constant. Now is the timestamp. That works for timestamp. Okay. Now today, infinity, epoch. Okay. I don't know how this is going to work without a timestamp. We will see. So if I just do now, I'm curious what'll happen. Column weight does not exist. Weight was supposed to be the value of name. So I've done this wrong. Somehow I have screwed up that. And I think, really? So I'm looking down here. I'm wondering if it's spaces, quotes, something. Column weight does not exist. Yeah. Oh, what? Oh, I'm losing my mind. Why is it asking for that? That's okay. Huh. I feel like I'm missing something. I feel like I've run into this before and solved it, and I don't know how. It's really frustrating. Timestamp with time zone, and then we do quotes. Does that work? Well, so there's probably a better way to do this. I'm gonna figure the best way to do this out. That makes more sense than guessing something bad. So we're gonna do timestamp Postgres using timestamp now. It's a function, current timestamp. Ah, that would be handy. Current timestamp function. And so mostly one of the nice things that I like about Docker is we can just recreate things. We can kind of just blow things away if we screw things up and retry. Especially right now, none of what I'm doing is going to stay. I want to make that clear. None of this is going to be how we actually do this in the final project. This is me figuring all of this out, so I know I can plan the next bits. And so that's what we're trying to do. Current timestamp function. Okay, timestamp. We could have given it a default value. We could update our table. Then we wouldn't need to do anything. That's kind of handy, actually. Do we want to bother figuring out how to update a table, or do we want to just recreate the database? That could work, but we might. I feel like because I've used something like this before. I know I have. I just don't know how. Oh, okay. Current timestamp might be a newer feature because we moved back 3 versions from 13 to 10, and maybe we lost something there. We can probably update this again and it should be fine, especially going forward. I think that'd probably be fine, but that should at least give us a value, which we should be able to use here. Does that help? No, health does not exist. Health, capitals, no. Health. Sad face. I don't know what's going on. We can't connect. Okay. That should have broken something. The fact that didn't has me concerned. Why do both of those work? Oh. Maybe both of them work. I may need to figure out how all of this weird DNS magic happens. I honestly don't know, and that is a very deep hole that I don't want to dive into right now. So we're not going to. That's interesting that we get the same thing from both of those. I still don't know why this table is saying it doesn't exist, though. That doesn't seem good. So if we select star from health, we get this. Is there a psql commit changes? So I'm wondering if like there's some weird transaction that got created. Because I didn't start a transaction. If you're not familiar, transactions are a way to run multiple things as sort of a group. And if one of them fails, it gives you ways to kind of roll, because all of it's a group, you can kind of roll all of the operations back if something happens, or commit or not commit, depending on what ends up happening. But we weren't using that. And so I'm not entirely sure. We might just retry this. Create table, health, name, varchar 40, not null, value, name, not null, primary key. It shouldn't need to be a I am not entirely sure why we're getting this error. Health does not exist. All right, so this is them recommending to restrict permissions, because basically what it's going to do is just run arbitrary SQL, get the results, and then format them into some nice tables for us. But we don't need to worry about that because, again, local and also test. But in the final thing, we should probably actually care a little bit more about that. Why is this being weird? Default. Okay. Password, that seems fine. Database isn't fine. Oh. Database. This shows a lot. And I'm sure people have to have noticed. What is the default database for Postgres? Because it's not health. If it has the value of Postgres, user will be used. Okay, so it's Postgres, not any of the other Postgres. Save and test. Perfect. All right. The tables are something entirely different. We'll get into those once we do this, which just worked because I'm silly and was thinking of weird things and was tired and I'm making up excuses because I should have known this. Databases are not tables. Tables are in databases. So a database can have a series of tables, but there can be multiple databases that do different things. And so we just created a database for Postgres. Now we need to go do something else. We need to go and create a dashboard. Perfect. It's asking to save some of that stuff. We're not going to do that because saving passwords for localhost is madness that I don't need. So it's going to give us this fun little query builder. You can see it's already kind of figured out what's going on. Because we have a timestamp and we have values, it already knows that we want to pull from health, a health table this time, and use the time column of created time to select the value and then filter based on some time filter. So the time filter is a special Grafana thing that is this. So it looks like a 6-hour period. That gives you a way to kind of customize things. So if we want to zoom in on some area, it can adjust that time filter for you. And then that changes your query and you run a different query and get different results. But there is our one result. The cool thing is this should be happening more or less in real time. So if I go back here and change this to 20, for example, we insert another row, we get a new value. And so if I come back here and refresh this, we should, this isn't going to work because I have the wrong time range. But if we go back 6 hours again, you can now see we've dropped. So we've gone from 100 down to 20. This is probably not healthy if this is weight, but there's a bunch of other things that we can do. This gives us a nice way to kind of graph these things. And we can save this. It's been a while since I've used Grafana, so we're going to apply that. There we go. There is our panel. So we can move this wherever we want, do all sorts of things, customize it and manipulate it, and apparently add annotations. I didn't mean to do that. There's other useful things we can do, like create alerts. So we can say if this valued every 1 minute for 5 minutes, when the average of 5 minutes is above 200, then do something, let's say 75, then do something. We can have it send a message or do anything like you can connect this to an alerting service that you have, whatever. This is probably more useful for actual things, but if you want to like have some specific calorie goal or something, I guess we could do that. I'm probably never going to use this, but this can actually be a really useful feature to kind of indicate like places your application should never exceed. And so you can kind of customize these based off of whatever you want. It has some basic stuff for building out these queries for you, but you can customize it as much as you need. These are just basic math things. So yeah, that is all of that. I don't know what transform is. I haven't played with that. There's a bunch of other things to kind of make that apparently has bars. Cool. We can do all sorts of things. The point here is we have a way to kind of display all of this information. And so the next steps are going to be, one, automating that table creation so that we have some way to do that. Figuring out a way to actually back up this data. There's options there. We can choose some sort of managed thing. The problem with that is that costs money. So we'd have to pay some cloud provider some amount of money to maintain a database for us. And then we kind of lose the advantage of having this like isolated and off of the network. We would absolutely need to connect to the network if we wanted to manage it. So that's an option, but it saves some headaches and opens up others. But we can do all sorts of things to kind of customize this. And as we get more things, we can do that. There's probably a better way than what we're doing right now to insert data into this. It would be cool if there was like some online portal on one of my local somethings that I could just go to and enter something and get it thrown in. Even if it's like a super simple like web form thing with like three tables. That could be useful. So this is pretty much it though. This is sort of where I wanted to get. This probably took a lot longer than it probably should have. That's both simultaneously the point and not the point of this. It lets us dive a little bit more into this and kind of do this more freeform. So hopefully you get to learn while I'm learning. This is probably one of the things that I'm more familiar with, but it's also one of the things that I haven't really touched in a while. And so a lot of the knowledge is slowly like atrophied out. And so we just need to kind of build some of that back up. And so that's sort of part of the goal here, is to kind of get some of that back. And we can hopefully do that over the course of this project. But hopefully this is sort of an interesting set of projects. I don't know how many I have planned for this, but I think there's going to be 5 projects. I want to say 5, because we're going to be, the way this ends up working out, I'm starting this late June, and the idea is to do this all the way through July, and I think that works out to 5. And so there'll be 4 after this of random projects. I have a list of things that I kind of thought would be fun, but if you have projects that you're like, this would be cool, try this, whether it's a game or some application or something, feel free to call that out or let me know on Discord, and I can take a look. I can't make many promises because there's other things that have to go on, and it really depends on both what I'm hoping to get out of it and learn, but also like what my schedule is. Some of these things are going to be intentionally less work than others, just to kind of fit everything, because otherwise just spending an entire month programming is just a lot. And so we're gonna try to avoid that. But hopefully this is fun. Hopefully it covers a few things that you haven't touched or haven't been hoping to learn a little bit more about. if there's things that I can dive into a little bit more that aren't too far off of where we're already heading with the project, I'm happy to kind of take those detours and explore them. The goal here is just deliver a complete thing on Sunday, whenever that is. There may be some crunch for some of these, hopefully not too much. If I do my job right, there won't be. But sometimes there's scope creep or just I can't figure it out. But anyway, yeah, that's pretty much it. So I will leave it here. I'll stop rambling and finish it up. So thanks so much for watching, and I will see you in the next video. So until then, see you, internet.